Okay, I'll get going if that's all right with everyone. So I'm still stuck in this JavaScript section, and we're talking about JavaScript functions. So if we try and pick up the story where we left it off. Where we left it off was talking about higher order functions. Which, as you remember, a higher order function is a function that takes another function as a parameter, and we refer to the higher order function as a callback. And just by way of example, I decided to use the array data structure, which has a number of higher order function methods associated with it. And as well, I suppose you could argue I overcomplicated it, but there's a method to my madness. I brought in a web API into the demonstrations that I'm working my way through. And it's the random user web API, which allows us to send requests to it across the HTTP protocol, and it will send back an array of objects where each object is a randomly generated user profile, which has lots of properties in it. So it's a nice little addition to the case study, if you like. This was the architecture or the structure of our demos. Again, it's complicated, arguably, but you'll see that this kind of structure is very similar to how React apps work. So that's my rationale for it. I'm not going to go explaining this again because you can look back at the previous video if you want an explanation, but I'm just trying to refresh your memories to get us going. And so so then we started looking at some sample scripts. The first sample script is using the for each higher order function. And I'm just going to quickly go back to that one. If I enable it. Sorry, now I'm just playing with something here for a second. If I enable it and save that and start my live server. I think I did it again. I enabled the wrong one. Okay, so that's what the script is generating. And the reason I'm going back to the base example, if you like, is just to make it clear to us that there is something unusual going on in this code. This code, although it seems to be synchronous in the sense that it executes in the order in which you see it here, it's not really. I'm not sure if I mentioned this to you the last time. So if you see this console.log statement down here at the end, which is outside, if you like, all the fetch related code, then your initial reaction might be, well, that console.log is going to appear at the end of the output generated in the browser's console. But in fact, it isn't, because if we look, if I save that change and go back to the browser, you can see that the end actually appears at the beginning of the output. And so that tells us there's something unusual going on. And what is going on is the fact that this fetch statement, which, okay, it begins up here and it kind of encompasses all of this, it executes asynchronously, which kind of means it executes not immediately, but sometime in the future. And then the future is dictated by how quickly our web API responds back with the data. So in fact, the order in which things happen is the fetch makes its call to the web API. When the response starts to come back, and it may be fragmented, but when it starts to come back, then this callback is executed. And when all of the fragments have been returned by the web API and they have been reassembled and the body of the response has been extracted and converted into from JSON to JavaScript, it's only then that this callback executes. Okay, so that's all happening in the future. Now, in the meantime, while the browser is waiting for all of that to happen, well, it doesn't wait actually. What it decides is, well, I'm going to continue on and execute whatever else is in this script file, which is why the console.log actually happened first, because all of this stuff up here happens later on, if you like. Okay. Does that pose any questions, I wonder? No. Right. So, but in terms of higher order functions, that sample that I was just looking at there demonstrates the use of the for each higher order function. The filter function is our method, stroke function, is another higher order function associated with the array data type. And what the filter function does is it takes source array and it goes through them one by one, and it identifies entries in the array that satisfy a particular condition, and you express the condition in the callback that you pass to the filter method. And what the filter method returns is a completely new array with references to the entries in the source array that satisfied the condition. It doesn't change the source array. So the sample that we were looking at the last day at the very end, I think, but I am just going back to just so that I think I kind of rushed it really, but I'm sure you got the point, but just to be sure. So now I want to enable this guy here and disable the other one, just so that I don't want to clutter the output. Save it. And if we look at the script in particular, so, I'm not going to go explaining all this stuff up here now because that's the same as before. So where the story changes is in the callback that we pass to the second then. So now again, I have my full array of user profiles. And again, I asked it for 10 user profiles. So what I want to go processing it. My first objective is to find all profiles that relate to females. And I know from studying the structure of the objects that are returned by the random user web API that there is a property in each of the objects called gender, and it's either set to the string male or female. Now, in order to achieve that objective, as I was saying at the very end of the lecture the last day, I could write a kind of a standard for loop that goes through it. But we don't need to do that. We should use the filter method instead. And the filter method takes a callback. And in the callback, what you've got to do is you've got to code the condition that determines whether the current entry of the array that's being looked at should be put into the output array or not. And that's what I'm doing in the return statement here. This return statement is evaluating the gender property of the current profile object that's being looked at. And if it's true, then it puts it into the output array. So this console.log here should only have females in it. Right, at last, all females. And I'll just re-enable this up here. Every time I save this file or change it and save it, a new request is going to be sent out to the web API because it essentially refreshes the browser every time automatically. That's just by the way, and it's, you know, it's a different set of profiles that's being returned every time. So this is the full set of profiles that's returned. And this is the set that are just females. Okay. Took longer than I thought to get there. Let's move on. Second objective, just another illustration really, which says here, I want to just pick out males over 40. You know, I'm using the shorthand. Well, I'm just using the arrow function, which I can now use above, I suppose, really. But it's just another example. Again, my callback to the filter has to return a Boolean, and indeed that Boolean expression is the criteria by which I want objects added to this array. And if I enable that, save it and go back to here, and if you examine the third console log, looks like there were none. I'll do a refresh. Oops, did it again. This isn't my evening, I think. Sorry about that. Now I'm going to go back again and kill this and start yet again. Okay, so two males, and if you explored it further, you'd find that both of them were under the age expressed in the condition. So that's filter, just two examples of it. Next is the map higher order function. Now what map does is it takes your source array and it generates an output array, and there's a one-to-one in terms of number of entries in the output array, and each entry in the output array is computed by its corresponding entry in the input array, and that computation is dictated by the callback that you pass to the map method. Okay, so if I've got 10 entries in my source array, there's going to be 10 entries in the array output array generated by map. The first entry in the output array is computed from the first entry in the input array, and so on and so forth. So if we look at how I demonstrated that, so the first thing I want to do is I want to create an array of objects where each object just has a person's name and email. Again, you know, you could do it with just some sort of for loop, but map is ideal for that. And here's the callback that I'm passing to map. And in this case, anyway, it's just a one-liner. This return statement is constructing the entry that I want to put in the output array. So my output array is going to have a whole series of objects that look like this. And we'll just confirm that. And you can see there are 10 objects in the profiles array. There are also 10 objects in the output array generated by that callback, and they do indeed have the structure as I explained. There's another example of map here, which is, what's the objective? Just want to create an array of people's ages. So in this case, this output array is just an array of numbers, and you can confirm that that is what's actually generated yourselves. So that's filter and map. Then the third and last one that I wanted to look at, although there are others, is the reduce higher order function, which is quite different from the ones that we've looked at so far now. The idea behind the reduce higher order function is you're taking the source array or input array and you want to reduce it to a single value or an accumulator. And the way the accumulator is computed is you go through each entry in the input array, do some sort of computation, add that computation to the accumulator that you're building up as you work your way through the source array or input array one by one. Now, the accumulator can be of any type. You know, the simplest would be, it might be just a primitive that you keep adding to or extending, but it could be an object as well that you keep building as you work your way through each entry in the source array. So again, the reduce takes a callback, and it's inside in the callback is where you build the accumulator. It takes a second argument as well, though, and the second argument you set to the initial value for the accumulator, and that can be important. It can be important that you get that right. But for now, that's what the purpose of the second argument to reduce is. And so the way it works is, as before, the callback is invoked once for each entry in the input array. But notice in this case that the parameters that are passed to the callback, the first parameter is the current value of the accumulator. Obviously, that's changing as you work your way through. The rest of the arguments then to the callback are the same as before. This would be a reference to the current entry in the input array that's being processed. This would be its index, and this would be the full array. We don't tend to use this one. I'm not using either of these, actually. I'm only interested in this one and in this one. But you've got to pass the accumulator, essentially, you've got to pass the accumulator on as you work your way through the various elements in the input array. The other point to note is the callback has to return the updated accumulator. So somewhere in here is where you have the code that will take the current accumulator value and update it based on the current entry that's being processed. And then critically, it must return it at the end, because what it returns is what dictates, is passed into the next invocation of our callback. So there are typical mistakes that you make. You forget to return the updated accumulator, or your initial value for the accumulator hasn't been chosen properly. So let's look at an example. I've got a couple of usages of the reducer now. So the first one is the simplest kind of one-on-one example. I want to compute the average age of all of the profiles. So what I'm going to use the reducer to do is to compute the total of all of the ages. And then I can just calculate the average separately by dividing it by the number of profiles in the input array. And so here we go with our reducer. The initial value for my accumulator clearly is going to be 0. The ultimate value here is going to be the total of all of the ages of the profiles. And in the body, what I'm returning each time is the current value of the accumulator. Okay, that's what's being passed on from invocation to invocation. The current value of the accumulator plus the current user's age. And I'm returning that. So there's no, that if you like, is the computation of the update that I need to carry out to my accumulator. So that's the simplest example of a reducer. Moving on. Here I want to find the, sorry, what am I doing? Oh yeah, find the youngest person in the array of profiles. Now, you know, with the reducer higher order function, understanding the code, you've had one or two explanations of it, understanding the code is straightforward. The challenging part is realizing that if somebody said to you, I want you to write the code to do that, realizing that you should use the reducer higher order function, making that decision is actually the difficult part, or realizing that the reducer is the way to go about solving that particular problem. And once you've realized that, then the implementation, I think anyway, is straightforward enough in some cases. So again, if this is my objective, then realizing that I should use the reducer function to do that is an important first step. And so here's the code. Just commented it out for myself. The next important decision is realizing that the initial value for the accumulator should be something very high. Based on the fact I'm looking for the youngest, then if 100 is my initial value, then I'm bound to find at least one, hopefully a lot more, people in the array of profiles that are lower than that. If I set the initial value to 0, then based on how I've written the callback, I'm not going to find anybody whose age is less than that. And so the overall answer is going to be 0. So as I've said a moment ago, getting the initial value, choosing that correctly is an important decision as well. And so on the body of the callback, I'm just, what am I doing? I'm checking the person's age. Look, I'm just doing a simple comparison here. Is the current person's age less than the minimum that I've found so far? Minimum is the accumulator that I'm passing on from invocation to invocation. And if that expression is true, then set profiles, set the current person's age to this variable here. Otherwise, set it to the same minimum. Don't change it, in other words. But I always have to return this thing. Okay, so this, I'm returning the current youngest age that I've found so far. So in terms of accumulating, we're not really doing an accumulation here. We're just looking for, one particular value within the array. And again, you could have done that with a for loop, but that wouldn't be the kind of JavaScript way, if you like. You can study this code later on yourself. The third example is certainly the hardest of the three that I could come up with. The third example, what I want to do is, this is my accumulator, okay? I want to compute how many people are less than 25 in the array, how many are between 25 and 50, how many are in this age group, and how many are in this age group. So this is the structure of my accumulator. And also what I've just highlighted there is the initial value of my accumulator. Now, I've also just written some convenience code for myself here. I'm just creating a little, I'm going through the array that I've just shown you, the object that I've just shown you there, and I'm extracting all of the keys. So this variable here is going to have these strings in it. Next, I've written a little convenience function for myself, which is this one here. And what that function is going to be used for is if you pass it in an age, a number in other words, if you pass it in a number, it will work out which of the age categories that belongs to, and it will return one of the entries in this array here, which really means it's returning one of these keys up here because of the way that I've constructed this array. Okay, so the purpose of this function is to take a number and return the key that it is related to. And finally, I have my reducer. And so in the callback to the reducer, I take the current person's age and I find which category that age is in. But it's not so much that I'm finding the category. What I really want to know is which of the keys in my object there at the top, which of the keys does it belong to? Which of these keys does that person's age belong to? And once I've found that key, then I just increment the value associated with the key. This is where I'm, sorry. Yeah, this is where I'm incrementing the relevant entry in my object structure there at the top. And as usual, I'm returning my accumulator. So again, without over explaining things, this is the structure of my accumulator. This is the initial value for the accumulator. And as I'm working my way through the array of profiles, one of these numbers here is going to be incremented for each person that I process. And then eventually I just console log it. So you can explore that code yourself in your own time. Certainly the third example is the trickiest one that you might come across. I'll pause for any questions, but I'm not sure if it's too late in the afternoon now to be studying this kind of stuff. No? Right. Eventually, I've got to the end of this set of slides. Now, there are other aspects to the JavaScript language which I haven't covered, but we will cover it as we need it when we work our way through the React framework and the Node.js stuff. There are things like, for example, destructuring and the spread operator, which some of you may have come across if you've done any kind of modern JavaScript programming in your own time. I haven't mentioned those, but we do use them a lot in our code, so I'll explain them as I need to, as they arise.